and we're going to be graphing triangles, but the weird thing is they're going to tell us how long the sides are with variables. So the side isn't going to be 6 long, it's going to be d long. So go ahead, write that title, write down what it says in example 1, and then draw yourself an axis that like you see up there. You'll notice as you're writing down example 1, there are going to be 2 parts to all of these problems. We're going to graph it, which we're going to make the picture, and then we're going to label it, which means we're going to say what the coordinates are. And it's a little weird because there aren't really numbers, but I think you guys will do fine with this. Okay, as you're writing it, you'll realize that the triangle that we're going to be making is a right triangle. Now, I'm going to preface this by saying that there are many ways you could draw this correctly, just like a lot of geometry. So if you kind of see a different way than I'm drawing, that's fine. When I know that I have to draw a right angle, isn't there kind of a right angle already built into the axes? I'm going to use that. So here's what I'm going to do. Because it's right triangle XYZ, I am going to use the right angle I already have built into this. So I'm going to draw my right triangle like this. Just kind of built that already built in right angle I'm going to use, which is going to make life a little bit easier in just a minute. Okay, now it says that this is triangle XYZ. So I'm going to label the vertices with X, Y, and Z. Honestly, it doesn't matter where you put those letters. So we could all have different spots. I'm going to put X, Y, and Z in these spots. And then it tells me that leg XZ is D units long. So I'm going to put a D there so I know that it's D units long. However big D is, that's how long it is. Okay, now have I taken all the information they've given me and put it on my graph? Yes. I have a right triangle. It's a triangle XYZ. Leg XZ is D. So I've used all that information. That's this part. That's the graphing part. When you take all the information and you get it on the picture. The labeling part is where you take each of the vertices and we're going to give them a coordinate. So we're going to say like where we would graph each of those corners of the triangle. So this is the second part we're going to do. Now, maybe you see why I like to use this corner. Isn't X a really easy coordinate? It's right there in the center. That's easy. I always try to use that center if I can because that's 1/3 of my points are really easy to get. Okay, now I'm going to look at Z. So this right here has to be how far over on the x-axis it is. So how far have I gone on the x-axis? D. Now that's going to bug some of you because that's not really a number, but I've gone over D units. That's how long I've gone. How high up has D gone? 0. It hasn't gone up at all. So my coordinate for Z is D0. A little bit weird, but we've been in algebra. We know that variables are a part of life. Okay, now let's look at Y. This point right here, how far over on the x-axis has it gone? 0. So that's my x value. Okay, now, for how high up it's gone, I don't know. I don't know how high Y is, so I'm going to make something up. You can pick any variable you want, except for D, because we've already used D. So I'm going to pick J. That's how high it is. You might want to pick K. You might want to pick A, but it's got to be some variable besides the one that we used. So that's what we're doing. We're going to practice this because this is a foreign thing, but we're taking the information and putting it on the picture, and then we're labeling all three corners. So right now, out of the gate, anything you want to ask on that one? Jasmine.
Actually, on this one, it should be like go off. Okay, I'll just ask you.
Okay.
So what is it a right triangle and it's actually like in one of these squares? Do we use variables for both?
Yes, I'm glad you asked that. We're going to do this one next. So you're kind of asking like maybe it's not built right in here. Maybe it's over in here. Okay, let's do another one and this will help. Great question. Okay, so here's our second example, and we're going to make this all in one of the quadrants instead of just kind of built in. Okay, so this one is going to be an isosceles triangle called RST. The base is going to be RS, and that base is going to be 4A units long. Okay, now, as we kind of start to think about this, isosceles means that we have at least two congruent sides. I am still going to use this as the anchor for one of my triangles ends, but I'm going to put everything else in this part. So here's how I'm going to make my triangle. I'm going to use this corner, but then draw it like this. And I'm going to make these two sides my two equal sides. Okay, now this one, it matters where I put my letters because they said the base was RS. And so in this picture, my base is that bottom line. So this is RS, and that leaves T for my vertex angle. Okay, so let me see. I've got an isosceles triangle. I've named it RST. I have a base that's RS. The only thing left is to actually say how long that base is, which is 4A units long. Okay, so I've taken all that information, I've put it on my picture. That's the first half of it, graphing it. The second half of the process is to give coordinates to all the corners. I've still got a super easy one. R is going to be what coordinate? 0, 0. Good. Okay, now let's look at S. How far over on the x-axis is it? 4A. Okay, how high up on the y-axis is it? 0. Okay, now, here's where we got to put a little thought into this for T. If T is the vertex angle of two equal sides, and this bottom is 4A. Do you know how far over T has to be? 2A. Good. Whenever you have isosceles, it's going to be over exactly half of the base because it's in the middle of the base. So half of 4A is 2A. Now, do we have any information on how high up that peak is? No, we don't. So we pick any variable except what letter can't we use? A. We could pick, I'm feeling like a Z right now. But any variable you want except for A. Maybe you want to get into your Greek letters and you want to pick theta. That's okay. But pick anything besides your A. And that's how we'll do that one. Does that help a little bit with that question? Okay. Any other questions on this point right now? Okay, let's try another one. Let's do an isosceles right triangle. So we've done a right triangle, we've done an isosceles triangle. Let's do an isosceles right. Whenever we draw any kind of right triangle, I think it's in your best interest to kind of build it in. So I'm going to build this one in what I have already. It just is going to make our math a lot easier and that kind of thing. So I'm going to build in this right triangle into the corner I already have. I think, I'm not telling you you can't, but usually it's easier to keep it on this side because those are all positive values. You could go this way, but you got to make sure and worry about negative values then. But those are some tips. When I draw my isosceles right triangle, I'm going to build it right here. And my two congruent sides have to be right there, because this hypotenuse would be longer than the other two. Okay, now, I know the three letters are going to be D, E, and F. Does it have any stipulations about where those letters have to go? No. So we have lots of options where we want to put those letters. And then it says the legs are E units long. And since we're with an isosceles triangle, remember that the legs are the two congruent sides. So both of these are E long. Okay, so I've got an isosceles right triangle. I've labeled them with D, E, F, and I've made the legs E units long. So I've graphed everything they told me I could graph. Now I've got to label all of the corners. Alright, well D's my easy one. If you do things right, you'll always have that easy one. 0, 0. Okay, for F, how far over on the x-axis is it? E. How high up is it? Good. Okay, so there's our F. It's over E. Up, nothing. For this point up here, bless you, point E, how far over on the x-axis is it? 0. How high up is it? E. Bam, done. Easy as that. Questions on that one? Alright, good, good, good. Okay, now, maybe, just a second. We're going to do a backwards version. I'm going to have you draw this, and we're going to find the missing mark. There, it looks very similar to one we've already done, but you'll have some you have to draw, some you just have to find the missing mark. What kind of triangle is this? What would we call this type? Isosceles, good. We've got two congruent sides. We've got a couple variables given to us in our coordinates. We've got a P in the mix and a Q in the mix. Up there, we would say that the base has to be AS, because that's the side that's not congruent. So if we were listing things like tomorrow when you have questions on isosceles triangles, the base is the non-congruent side. Do you remember what type of angle T is called, because it connects the legs? Vertex angle, good. There will be one question on your quiz tomorrow where I give you information, like I'll tell you what angle is the vertex angle and that kind of thing. And you probably want to draw the picture to give yourself an idea of what kind of math you want to do. Okay, the base, AS, how long is that base? 2p long? So if T has been moved over to the vertex angle, how far over has it gone? 1p. So we're going to put 1p there, or just a p is our little question mark. Q could be one of the answers they put up there. What else could we have put? S, you could have put J, B, as long as you pick something besides P. So that's not bad, right? Okay, so I'm going to do another example. This one I'll let you just watch. We'll just look at this next one. Okay, here is what we have. We have an isosceles right triangle, but they haven't used the corner for this one. Okay, so what we've got are sides R and S, and T and S are legs. They're congruent. How long is side RS? 2A long. Okay, so then that means that side ST has to be 2A units long as well, because they're congruent. Okay, so if we think about T, how far over is T? 2A. How high up is T? 2A. Bam, there we go. That's our answer for that one. Not too bad. Okay, well, bad news. I've only got one more for us to do. And I am going to have you draw this one because it's a kind that we haven't seen yet. This one is different because it actually goes into the other side of the graph. So this one we're going to have one more thing we have to be careful of. I think you guys will be fine though, but it kind of goes through the middle of the y-axis. This is triangle EFG. Also isosceles, is just a different way that it could be drawn. We've got 3 missing things we're going to need to find on this one. Okay, now here's the thing we have to be careful of. The base is not 2G units long. Does anybody know why the base is not 2G long? Yeah, Audrey. That's only one side of the graph. Good. It's how far it is from here to here. So this space is 2G long. So that's one thing we have to be careful of. Okay, so that point is given to us. Let's look at F first. How far over on the x-axis is F? 0. And then it's B high because we don't know how high it is. It's just not G high. We know that. Okay, now E has gone over into the negative territory. Well, if this is an isosceles triangle, if this side is 2G long, this side is 2g long. So when we figure out our x-axis and we figure out how far this has gone, it's gone 2g. But because it's gone this way, negative 2g is that part. And then how high up has it gone? 0. There we go. That's our section. Not too bad, right? Alright, we're going to stop there today. And here's